All right, so let's now go ahead and get started again. And we're still in 1.4. And we were looking at the quadratic formula and how we use that. Now, when we use the quadratic formula, we need to make sure as well that we don't have any fractions or any decimals, because they're difficult to work with in our quadratic formula. So let's look at another one of these, and we're going to solve this again with the quadratic formula. And this one's going to have decimals. Now, when we solve with the quadratic formula, you never want to use decimals or fractions inside of the quadratic formula. So if you have decimals or fractions, you need to get rid of them. In this case, we've got decimals, so we're going to get rid of our decimals. And we only have one decimal place, that's the most. So we can get rid of our decimals by multiplying everything by 10. And that's going to clear out all of our decimals. So that makes it then a 3x squared. We've got a minus 4x. And that makes it a 12. I'm going to move that over. So now we can apply our quadratic formula. So this one had decimals, and we got rid of it by multiplying by 10. So now we'll just move that 12 over. And we have 3x squared. We've got a minus 4x and a minus 12. That still equals 0. And let's make sure we're ready for the quadratic formula. Is it in the correct order? Yes. What do we know about our components? A is 3. B is that negative 4. And C is our negative 12. So that's what we do first. Make sure you label your components, your A, your B, and your C. Now we can apply our quadratic formula. So let's do that. I always like to, again, write up our formula. X equals minus B plus or minus the square root of B squared minus 4AC all over 2A. We take our time, plug our values in. Be very, very careful about double negatives, because that's where students make a mistake in many cases, is there. We've got the square root. We've got a negative 4 squared minus 4 times 3 times a minus 12. And that's all over 2 times 3. Double negative here makes that positive. So now we have a 4. Then we have a plus or minus. And then 2 times 3 is a 6 there. Let's try our discriminant next. And the discriminant, again, is just a fancy word for everything that's located underneath our square root. So what is underneath our square root? Well, we have a minus 4 squared. We have minus 4 times 3 times a negative 12. Let's kind of focus on what we're doing. You don't want to make mistakes. So now we have negative 4 squared, and negative 4 squared is a positive 16. Then we watch our signs. Negative times negative makes it a positive. Always do your signs first. 4 times 3 times 12. That's a 144. We add those together. And that gives you now a 160. if you solve it the way I'm solving it, they're not that difficult. We break it up into small pieces. That way it's not all at once. We do each piece individually. So we did our discriminant. We got to this part. Now we need to see if 160 will break down. 160 will. Has a 0, so I'm going to use a 16 and a 10. 16 is a perfect square of 4 and 4. So there's a pair of squares there. So 4s are going to come out. 10 breaks down into 2 and 5, but there's no other squares, so we're going to use the 10. So what do we have? We have 4, okay, plus or minus. 4 comes out, that's gone. 2 times 5 is that square root of 10, and that is all over now 6. Is everyone with that? So okay with that so far? So see what we've done. It's not difficult as long as you take your time with it. You can split this up into 4 over 6 plus or minus 4 square root of 10 over 6. We can reduce this down a bit because 4 over 6, well, that's 2/3. 4 and the 6 here can cancel, and that leaves you with a 2 square root of 10 over 3, right? Because that 4 and that 6 there cancel. We cannot break down the root because that 10 and that 6, they cannot cancel because that is a square root, that one is not. So but what you can do is the 4 and the 6 in front, those can be reduced down. Now, what's our two answers when we split them up? We have 2/3 plus 2 square root of 10 over 3. And we also have 2/3 minus 2 square root of 10 over 3. So those are our two final fully reduced down answers. I made that one up because that one has decimals, and I wanted to see how we clear the decimals out and work with those decimals. Now let's do one that has fractions. So let's say I gave you this one. Now, this one has fractions in it, and sometimes you might have the x in the denominator of that fraction, and that's okay because we'll just clear it out. So what do we have in our denominators? Well, when we look at this, when we have a variable, we look for the highest power in the denominator. And what's the highest power of x in my denominator? Well, the highest power of x in my denominator would be that x squared. So in order to clear out all of my fractions, I'm going to go ahead and multiply everything by an x squared. And then I'm going to go ahead and distribute that through. Now, when we're done, we may have something that we're going to have to rewrite in a completely different order. And that's okay. But make sure that you see how to clear them out by using that x squared. So when we do this, it's going to kind of mix up the order a bit. So when we distribute that x squared through, those cancel, and that leaves you with a 3. Now, x squared, we take away an x, so that leaves you then with a minus 5x, because 1 cancels down below, but 1 is left over. And then on the right-hand side, we have an 8x squared, because nothing can cancel with the x squared on the end here. Now, we still need to set this to 0. And since my x squared's on the right, I'm going to move everything to the right. So I'm going to move that 3 over, and I'm going to add that 5x as well. And I always like to keep things on the left, So it's still going to be equal to 0, but I'm going to rewrite it on the left. So we now have x squared. We have a plus 5x minus 3, and that now equals 0. So, are we ready for the quadratic formula? I think that we are. We've got it set to 0. We've got all of our fractions cleared out, and it's in the correct order. So, next step is we find our A, our B, and our C. The 8 is your A. The B is the 5. And the C is the negative 3. So everything has been labeled. Now we just write up our formula. So x equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. Now, on your exam, you don't have to memorize all the formulas. You can have either a page of notes or note cards. Once you've done a lot of these, though, you're probably going to have the formula memorized anyways. But if you struggle with memorizing things, then you can have a note card. Or stack of note cards or a page of notes. So if you wanted to, you could write that down somewhere. But after you've done it several times, usually students pick it up. Let's go ahead now and plug in our pieces. So we have a minus b, so that's a minus 5. Then we've got a plus or minus. And then we've got the square root of 5 squared minus 4 times 8 times a negative 3. And that is all over 2 times 8 again. So take your time. Don't rush through these. It's very easy to make a mistake. The quadratic formula is not difficult. It's just a matter of plugging in the values, taking your time, making sure that you don't make a sign error. Now, unlike the previous ones, that's going to stay negative because there's no double negative, so that's a negative 5 out in front. Then we have our plus or minus. We leave our root there. We'll come back to that in a moment. And then we have 2 times 8, which in this case is a 16. Let's now work with our discriminant. And our discriminant is 5 squared minus 4 times 8 times a negative 3. And 5 squared is 25. Negative and negative makes that positive again. 4 times 8 is 48. 4 times 8 is 32. Multiply that by a 3. That makes it a 96. So 4 times 8 is 32. Multiply that by 3. And we get that 96. It's negative and negative makes this then a what? Positive. So where students make a mistake at is the signs. I always look at this first. Negative and negative makes that positive. If you had 3 negatives, it would make it negative again. If you only had 1, it would stay negative. So always check your signs. Don't try to plug them in the calculator. You might make a mistake. Always predetermine what your signs are going to be. Now we can put these together. So we just simply add them together. And that gives you 121. Always, 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 whenever you get a square root, before you start breaking things down, you always check. So always use your calculator to check first. 121, right, if I check it, happens to be a perfect square of 11. So you don't have to try to factor it out. Always check first. You may have to, but always use your calculator first to see, is it already a square root? Because I would hate to have you work with some huge number only to find out it was already a perfect square to begin with. So 121 is a perfect square of 11. Now, let's write up our two answers. Let's see what we have. If I write up my two expressions to work with on this, what do I have? I have minus 5 plus 11 over 16. Right? And then we also have, because this breaks up into the two of them, a minus 5 minus 11 over 16. So there's the two of them. You're always going to have 2 because this breaks up into the two different parts here because of the plus or minus. This one's nice because it's a whole number. So now we have minus 5 plus 11. Well, minus 5 plus 11, that makes it a positive 6 over 16. And 6 over 16, these both have a 2 in common. So that's going to make that then a 3/8. What about the other one? Minus 5 minus 11, that makes it a minus 16 over 16. Minus 16 over 16 makes it a minus 1. So there are the two solutions that we have. We have a minus 1, and we also have a 3/8 that is positive. Is everyone okay with that? May come out to be a whole number like this one with 11. It may come out to be a square root that's got left over to work with. It may come out to be imaginary. It could have been, if this was a negative 121, it could have been then a square root of that negative 121 would make that 11i, right? Could have been non-real complex. It could have been a whole number like that 11. Could have been a variety of things. Could have been with the root left over as well. Let's try another one. This one's a little bit different as well. Still using the same quadratic formula. So we've seen how to use the quadratic formula. We talked about how to clear out the decimals, if you have them. We talked about how to clear out fractions, if you have them. Now we've got this to work with. Before we can do anything else, the order of operations says we need to do the parentheses first. So that's what we're going to have to do. We're going to have to break this up using the FOIL method to see what we can condense it down, eventually get it to 0, and then use the quadratic formula at the end. So before we can do much else with this, what we're going to have to do is we're going to have to FOIL. So let's go ahead and FOIL. So I'm going to work on the left-hand side, and I'm going to go ahead and FOIL. And we've got 4x minus 3, and we've got 2x minus 1. And so we're going to FOIL it. And remember how to FOIL. First times first. 4 times 2 makes it an 8x squared. Outside and outside, so that's 4x and a minus 1. Well, that makes it a minus 4x there. Inside and inside, minus 6x. And finally, last times last is a negative times a negative, and that makes that then a positive. These can go together, and we now have an 8x squared. We have a minus 10x and a positive 6. Is everyone okay with that so far? Now, what do we need to do from here? Well, irregardless of the method that we use, whether it is zero factor or whether it is the quadratic formula, this has to be set to 0. So I'm going to move this 10 over. And that leaves you then with this. Now, at the very beginning of class today, when we looked at one of the questions out of 1.4, I think it was question 3, we were able to reduce it down before we could factor. Same concept here. Always, always check your numbers. When I look at this, I have an 8, a 10, and a 4. Make it easier on yourself and reduce it. If you don't reduce it now, you're going to end up having to reduce it later. And it's going to be easier to make the numbers smaller now than to work with them later. So 8, 10, and 4, they all have a 2 in common. So I'm going to go ahead now and divide everything by a 2. That just reduces down the size of the numbers, makes the squares smaller and easier to work with. If you don't do it now, you're going to have to reduce down at the end. And it's always easier to do it at the beginning. So 8 over 2, that makes it a 4x squared. Negative 10 over 2, that makes it a 5x, that's negative. Negative 4 over 2, that makes it a negative 2. And 0 divided by any number is still 0. So now we have it reduced. It's all been FOILed out. It's now been set to 0. It's all in the correct order. So identify your components. A is 4. B is the negative 5 here. C is your negative 2. So now it's set up for the quadratic formula. Write that up and we'll apply it. If we left it as 8, negative 10, and 4, we could still do it, but the numbers would be larger. The squares would be more difficult to work with. And you really want to reduce it down and make those numbers as small as possible, because the larger the numbers in the quadratic formula, the more difficult it's going to be to factor them down and reduce those roots. So write up our formula. X equals minus b, plus or minus the square root of b squared minus 4ac, all over 2a. And now we plug our values in. And that's going to be a negative, watch your signs here, of a negative 5. And we've got plus or minus square root of negative 5 squared. Then we've got a minus 4 times 4 times a negative 2 again. That's all over 2 times 4. And we look for double negatives, and we have one. Negative and negative here. That's going to make that a positive 5. So that is copied down. We still have our plus or minus. We've got our root left over. And then we've got 2 times 4, which that makes that an 8 below. Split it up. We're going to now look at our discriminant. And our discriminant is minus 5 squared. Minus 4 times 4 times a negative 2. And negative 5 squared makes it 25. Watch your signs. Students make a mistake here. Negative and negative. 2 negatives make that positive. If students make a mistake, it's normally right here with those signs. So always check the signs first, write it down, and then just plug the numbers directly into your calculator. So if you plug them in, you have 4 times 4 times 2. Well, that makes it now a 32. We add our 25 and the 32 together, and that makes it a 57. Try to break down that 57 if we can. I don't think that 57 is going to break down any. 57 breaks up into 3 and 19. However, 19 won't go any further. So no pairs. So 57 is not going to break down at all. That's it. The square root of 57 stays as it is. So that makes it a little bit easier. Rewrite this as 5/8 plus or minus square root of 57 over 8. 5/8 does not break down. Nothing can reduce with that 8. So what are our two answers now going to be? They're going to be 5/8 plus the square root of 57 over 8. And the other one is 5/8 minus the square root of 57 over 8. And there are your two final factored and reduced answers. Let's do one more of these quadratic formula type of questions, and then we'll talk specifically about the discriminant. So let's do one more of these questions involving the quadratic formula, and we'll do another fraction one. Just so we have all the different types, we're going to do another fraction. I'll make this one pretty easy to clear the fractions. And there's one like this in your homework. It's question 8. Very, very similar, just a little bit different fractions. This one is not difficult at all to clear out. Most of these are not going to be difficult to clear. So how do we clear this one? Well, it's pretty easy and pretty obvious. We need to multiply everything by a 3. And that's going to clear out all of my fractions. And make sure when you distribute that 3 through that you also multiply it on the right hand side as well. So make sure it goes to that 3 also. And this one's, again, very simple to clear out. Just like your homework. The one in your homework has, I think, a denominator of a 9 and a 3. So it's basically the same, just a little bit different numbers. So we're going to use a 3 here. That's going to clear them out. You've cleared out fractions before, so this shouldn't be anything new. So clear them out, and that's going to make it a 5x squared minus 2x, and watch the other side. 3 times 3 makes it a 9. We'll move that 9 over. Now we've got 5x squared, a minus 2x, and a minus 9, and now that equals 0. So take our time. Make sure we got everything in the right order. Very, very important. It all is. Quadratic formula is not difficult. It's just easy to make a mistake and kind of time consuming. So A is 5, and I like to circle my negatives. That way we don't lose one of those. It's usually the simple things where students make a mistake. And that's the most frustrating part. Is a lot of times students know how to work things out, and they know the operations and the steps, but you make a sign error. And then you start doubting yourself when you get it wrong because you think you don't know what you're doing, but you do, but it might have just been a simple algebra mistake. So always take your time with the signs. Make sure everything looks right. Most of you know how to do the proper procedure. It's just simple things, like losing a sign somewhere, writing down a 3 instead of a 2. Those things happen, but try to avoid those as much as possible. So writing up our formula, x equals minus b, plus or minus the square root of b squared minus 4ac all over 2a. Plug in our values. Minus a minus 2 plus or minus the square root of a minus 2 squared minus 4 times a, which is 5, times c, which is a negative 9. And that again is all over 2 times 5. And it could very easily be imaginary underneath here too, with a negative. We just haven't done very many that are imaginary. This one comes out real again. But it could be that you get an imaginary number. It could be that you get an I somewhere, because the square root of a negative makes it an I. So just remember that can happen as well. And let's take our time and rewrite. Negative and negative. That's a positive 2. So that comes down. Then we've got our plus or minus. We have our square root left. And 2 times 5 makes it a 10. Next, we're going to look at our discriminant. And our discriminant is minus 2 squared minus 4 times 5 times a negative 9. Watch out for signs again. When you square a negative, that becomes a positive 4. Double negative here, negative and negative, makes that a positive. Then we've got 5 times 4, which is 20, times 9 should make it a 180. Adding those together, that's 184. Always check to make sure that your number is not a perfect square. We are not in luck because 184 is not a perfect square. Okay, 184 is not a perfect square. We tried it. Didn't come out. So that means we've got to try to factor it. Now, 184 is an even number. And let's see if 4 goes in there. You can use 2, but if 4 goes in there, you really want to start with that. So let's use a 4 and a 46. And let's try another 4. Another 4 does not go in there. What about a 2? A 2 will. And that's going to leave you with a 2 and a 23. But 23 is not going to go any further. But 4 breaks up into 2 and 2. So let's see what we've got. We've got a pair of 2s, so that comes out. Now, what's left underneath the root? Well, 2 and 23, nothing goes together, and 2 times 23 is your 46. The 46 is left underneath your root, or your radical, and that's still over 10. Break it up, reduce, and we are done. So that's 2 over 10, plus or minus 2 over 46 over 10. We've done many of these so far. 2 over 10, that's 1/5, plus or minus. 2's can reduce down there, and that leaves you with the square root of 46 over 5, because 2 and the 10 can cancel. Rewrite it, get my 2 solutions. So what are they? They are 1/5 plus the square root of 46 over 5. And the other one is 1/5 minus the square root of 46 over 5. So we've done a lot of these now that use the quadratic formula. We have one more part to cover out of 1.4, and that is just using the discriminant. And you can actually predict the number and the type of solutions using the discriminant. And we're going to be looking now at the table on page 138. So we're going to be looking at this table on page 138. And this is actually very simple. These are not going to be solved all the way out. All we need to do on questions 13 through 16 is we just need to determine the number and the type of solutions that we have. And that is done by looking at your discriminant. Here's what comes out of your discriminant, and here's the number and the type of solutions that we have. So if it's positive and it's also a perfect square, it has two solutions and they are rational. If it's positive but not a perfect square, something like 7, if you have, like, let's say left over the square root of 7, that would be a square root of 7, and that would give you then two solutions, and they are irrational. If it's 0, that's what's called a double root or double solution, and you only have one solution, and it's rational. If it's negative, you have 2, and they are non-real complex. So we're going to be referring back to this table on page 138 when we look at these last questions here. So we're going to be determining the number and the type of solutions using the discriminant. We're not going to be solving. And this is going to be for questions 13 through 16 in your homework. So for questions 13 through 16 in your homework, you're going to be using page 138 in your textbook, and your discriminant is b squared minus 4ac. So for these questions in your homework for 13 through 16, you're going to be using that page 138, and you're going to be using this formula for your discriminant. And here's going to be our directions. We're going to determine the number and type of solutions. We're not going to solve. So we are not going to be having to solve these. Okay. They're much simpler than the others. We're just going to be evaluating down the discriminant. And this is going to tell us the number and the type of solutions that we have. And they may not have the variable x, they may have a different variable, and that's okay as well. So let's say I just give you this one. This one's pretty simple, pretty easy to work with. We're not going to solve it. We are just going to use our discriminant. And then we'll look at our discriminant using that table on page 138. And that's going to tell us the number and the types of solutions that we have. Now, anytime we do basically any problem in 1-4, it's got to be set to 0. The only exception to that is going to be using the square root property. But any others, we set it to 0. So we're going to move that 14 over, and we're going to set it to 0. So just like we're solving with zero factor, or just like we're solving with the quadratic formula, it's going to be set to 0. Simple enough. Now we get our A, our B, and our C. So A is 9, B is 3, and C is that 14. Instead of having to work out the complete quadratic formula, all we have to do is look at our discriminant. Because for 13 through 16, all we need to do is determine the number and the type of solutions. So all we have to do is simply work with our discriminant. So use the discriminant formula. And that is b squared minus 4ac. We plug our values in. So that is 3 squared. We've got a minus 4 times 9 times 14. Go ahead and evaluate it down. 3 squared is 9. A single negative, that stays negative. That comes out to be a minus 504. That then gives you a discriminant of a minus 495, right? Okay, so we are not solving it. We are not using the quadratic formula. All we are doing is we are calculating the discriminant. Now, what do we know about the discriminant? The discriminant is negative. So how many solutions do we have? 2. And what are they? Non-real, I know it's hard to see, non-real complex. Okay. So we've got 2 solutions, and they are non-real complex. So that's all we have to write. 2 solutions, non-real complex. So 2 solutions that are non-real complex. Okay, easy enough on that. That's it. Let's do 1, maybe 2 more of these. I'd like to do one that's positive, and I'd also like to do one that has got a 0. In some cases, they might not be in the right order. So you have to be careful with that as well. You may have to rewrite them in the correct order, because this goes for the quadratic formula also. They may just be in a different order than what we need. And let's make this 10 a negative. That way it'll come out to be what I want. So let's make that, instead of a positive 10, let's make that a negative 10. I specifically picked this one because this is not in the correct order. When we use the quadratic formula, or when we find that discriminant, it has to be in the correct order. It has to be with the highest power first going down. So we have to now rewrite this as 9y squared plus 3y minus 10 equals 0. And by the way, our directions are just going to be determine the number and type of solutions. So we want to determine the number and the type of solutions that we have. Now we had to rewrite it in the correct order. And this may occur in the quadratic formula also. Make sure that your highest power is always first, and then it goes down from there. It's all in the correct order. So now let's go ahead and get our pieces. A is 9, B is 3, and C is a negative 10. We do not have to solve this out because we are determining the number and the type of solutions. So we're not going to have to solve it out. All we have to do is use our discriminant. And our discriminant, or should be finds to use, but we're going to go ahead and find that discriminant, and that discriminant is b squared minus 4ac. And that's going to be simple enough. We've got 3 squared minus 4 times 9 times a negative 10. And 3 squared is 9. 2 negatives makes that positive. And that comes out to be a 360, it looks like. When you put those together, that's 369. Now, we do not have to break this up. All we have to see is if this comes out to be a perfect square or not. So what do we have? We have 369. So it's easier to see on the screen here. We've got 369. Let's see if that's a perfect square. Is that a perfect square? Use your square root key. It is not a perfect square. So this is not a perfect square. If that would have been something like 49, it would be a perfect square, and it would be different. But this one is not a perfect square. Now we go back to our table, and we find it here. It's positive, but not a perfect square. So that means we have 2 solutions, right? And those 2 solutions are what? Are irrational. So we have 2 irrational solutions. So 2 solutions that are irrational. And that's it. Let's do one more. I just want to do one with a 0, just to make sure you've seen that one. Okay, so let's do one more of these. And again, same directions. Determine the number and type of solutions. Okay, make sure this is going to work here. Choose a minus 12x in the middle. Okay. So if I set this one up right, this one should come out to give you a 0 for your discriminant. And to do that, we set this to 0 again. And we need to get our a